Insurance adjusters are concerned about the high estimates they are receiving from Garage 1 for auto repairs compared to Garage 2. To verify their suspicions, each of 15 cars recently involved in an accident was taken to both garages for separate estimates of repair costs. Use a 2-sample t-test to analyze these data. Okay, these data are paired. Why? It's the same car, same damage, being evaluated 2 different places. So the level of damage doesn't change, right? It's 2 places evaluating the same thing. That's what makes it paired. Okay? All right, so we're going to use the SAS program to analyze the data. This part in here I have repeated, so that way if you're working on the handout and you're doing things in virtual SAS, you don't have to go back and track down the first handout where I had the virtual SAS instructions. Okay? What's different about it here is if you are using a standalone installation of SAS, you can change the path and the G path to go to your C drive or go to a USB device or whatever storage device you have. Okay? All right, so I closed the listing file, activated this because there are some graphics that I wanted, and so I turned those graphics on. All right, so the data that we input, I have the car information, the Garage 1 information, and the Garage 2 information. So come back up to the top. Car 1, 7.6 and 7.3. All right, so that's how. So knowing how to enter the data when the data are paired or independent or for the type of analysis we're doing is part of it. All right. So what I have to have. I don't have to have the information about which car it is. That's really for data management purposes. I don't need it in the analysis, but it's not bad to have it here. At a minimum, I need X1 or X variable and our Y variable or sample 1 and sample 2. Okay, and they have to occur on the same line for the ones that are the pair. Okay, now then I did this 2 different recovered the differences 2 different ways. I think you see 3 different procedures in this. Actually 4. Okay, so we have a difference. This is the D value in that hand calculation that we overviewed. I took Garage 1 minus Garage 2. If Garage 1 gives inflated estimates, these differences are going to tend to be positive, right? Most of us like to think about positive numbers better than negative numbers, but all right, so I have all the data input. All right. The first way I did it was did proc means, and I asked for a t-test with its significance level, and I did, whoops, I'm off screen. I did the confidence limits. I did the 2-sided. I should have probably put on a 1-sided there. And alpha equals 0.05. It defaults at alpha equals 0.05 if I don't pick it. But so, and I asked it to look at the means for both Garage 1 and Garage 2, and then also included that difference variable that I created. That would generate SAS output page. Well, no output pages since it's HTML. Third sheet of our handout. All right. It says the means procedure up here at the top. Okay. I got the information I requested in the order I requested it. Well, got a little bit of a formatting thing happening there when I dropped this into Word. Okay. So I have the means for both garages and the difference between them. It is the case with paired data that the difference between these 2 means is D bar. Okay, this last line down here, this is D bar. Okay, this 0.394365, etc., that is the standard deviation of those D's. 0.1018 is the standard deviation of those differences divided by the square root of the sample size. The value of T 6.02 is the mean divided by the standard error because the hypothesized value is 0. So if it takes D bar divided by its standard error, it's testing whether or not the average difference is 0. Okay, so here what's being tested is whether or not and let's just say this one right here. This is testing whether mu1 minus mu2 is equal to 0 versus the two-sided alternative. And I know it's two-sided because of the absolute value bars on the t up here. Okay. It also did the 95% confidence intervals for the difference, as well as the confidence intervals for the individuals. So if we do come up saying that there is a difference, we could also say, look at garage 1, kind of make if indeed they are giving us high estimates. Okay? And so based on proc means alone, I would say what? Well, for any reasonable alpha, because it's less than 1/10,000th, right? But so let's say alpha is, we didn't have one given, did we? No. For 0.05 guys, though, mostly, aren't we? All right. So at alpha equals 0.05, what would you conclude? They are different. That's the initial part of it. If they are different, one is higher. Which one is higher, and how do you tell? Okay. Garage 1 is higher because if we come back up here, this difference is positive, and I remember I took garage 1 minus garage 2, or I can simply look at the means. Okay, and come to the conclusion then that garage 1 gives higher estimates than garage 2. Now, as far as I know, proc means will only do this probability for t for a two-sided test. Okay, proc t-test, there are some older handouts that I've written that don't have the one-sided notation we're just about to get into. Okay, the next procedure we look at, proc t-test, so that's not a typo, it's two different t's. Proc t-test then works with paired data, and it does an upper test, a lower test, or a two-sided test. That's a neat option now to have. It hasn't always been there. All right, so if it does an upper tail test, okay, then it's going to compute a confidence lower bound. And that information is given down here at the bottom. All right, if it's an upper side test, it gives a confidence lower limit for the mean, which we know go together, right? Okay, and then also for so two-sided test, and we get a confidence interval, lower-sided test, and then we get an upper confidence limit for the mean. Okay, so I did them even though not both of these are not correct. The question is a one-sided test. I just wanted to show you what those look like. Okay. So proc t-test, we did this one. Proc t-test, I'm going to keep things at alpha equals 0.05. Up here it was a 0.05 for a two-sided confidence interval. This is 0.05 for a one-sided interval or confidence lower limit. The paired statement, which two variables do you wish to compute the difference across? So we could do the paired statement. We can do garage 1 by garage 2. Okay, so that's going to take garage 1 minus garage 2. Okay, if we do garage 1 minus garage 2, we're testing whether or not that difference is positive or greater than 0, right? Okay, so this part here generates garage 1 minus garage 2. All right, and so that would mean our H1 is a right-hand test, so that hence the U for upper. Now again, whether this becomes a right-hand test or a left-hand test is up to you. Okay, so if you did 2 minus 1, then it becomes a left side test. Okay, so here this is telling me it's going to do garage 2 minus garage 1. And we're testing whether that's less than 0. Here it's doing garage 1 minus garage 2, but it's doing the two-sided test, which is going to be analogous to this one up here. Okay, so here our H1 is just that garage 1 minus garage 2 is different from 0. The other thing is Proc T-Test now has these some automatic graphics built in. Okay, so the differences in the code here. Notice this one I wrote plots equals none because I didn't want to, once I did them once, I didn't want them 3 more times or 2 more times. Okay, so I'd suppress the graphs by writing plots equals none here. Okay, so having a look at those. The paired t-test, right, and so you can see also back in the program where I write this, a one-sided test to the right. Okay, and you'll see that up at the top here. Okay, so I still have here the number of differences, the mean difference, standard deviation. Notice this information here matches the difference that I hard-coded in there, the garage 1 minus garage 2, that diff variable. All right, and so I get that same information. I get the confidence interval for the okay, for the mean. It says the confidence limit for the mean, it goes from 0.43 to infinity. Okay, all we want is confidence lower bound. Okay, so this value here is the we wrote, I didn't say lower bound in class, I think we did confidence 95% lower limit, wasn't it? Confidence lower limit for mu, and it's 95%. Yep. So you don't have to worry about the infinity. In our textbook, we didn't talk about an interval. We just came up with a lower limit or an upper limit. It did a confidence interval for standard deviation here too. Standard deviation of the differences, which we didn't talk about. This 6.02 up here is exactly the same thing here. Here it's probability greater than t, no absolute value bars because it's a one-sided test. It's still extreme. So hence they're the same p-values from here to here. Okay, that doesn't always happen. Okay, it's just because it is such a large t statistic. All right, so from either one of these things, you would conclude that what? That garage 1 does inflate its estimates or has inflated estimates. How was that phrased to us? Garage 1 estimates do tend to be higher than garage 2. We would cite, we mentioned it earlier, I didn't write it down. All right, say we're at alpha equals 0.05. Our t statistic with 14 degrees of freedom is 6.02, and our p-value is less than 1/10,000th. It's right off of here. Okay, I'm looking at the computer output. Everything's there for me. I don't need to do a rejection region. I've got the p-value. All I have to do is make my decision, right? If you have the p-value, just compare it to your alpha. If I give you part of a computer output, you may have to generate p-values or compute t. If you give it all the information, other information is there. Okay? We doing okay so far? Program back over here. All right, here I did that was a upper test. Okay, now the lower test, or the test to the left. Notice the order here is different. It's garage 2 asterisk garage 1. Different order here versus here. Okay. If I would have put garage 1, garage 2 here in a left side test, I don't have any evidence to support that. I'd have a very large p-value, essentially 1. Okay, so once we make our decision, so write out your research question. Is garage 1 greater than garage 2? Take the difference however you like, either this way or this way, and then decide on the sides equals lower or upper. Okay. So the second one, when we skip down past the graphs, I'll come back to those in just a minute. One-sided left. And put the one-sided right behind it here. At the top of the screen is the one-sided right. This is the one-sided left. Down here, the new information. So notice the mean is just the opposite in sign. Variance information is the same. The min and max are in the negatives in the reverse order. Okay. Here I have negative 0.6133 is our observed mean. It goes from negative infinity. This is our confidence upper bound, right? Okay, this upper bound is less than 0, so it does support this. So again, just like we saw on the previous one, I'm not interested in this negative infinity part here, but this is going to be my 95% confidence upper limit for mu. The t value now is negative 6.02, and it's got, notice here, probability less than t versus what we have up above here. Just a little bit bigger look. There we go. All right, so this was the first one. We had a right-hand test, and the p-values, we see the left-hand test. So you saw how we've been writing those t expressions, or pardon me, those p-value expressions, probability that t is bigger than this or t less than this. We're doing the same thing right here. Okay. Sides equal 2, suppress the plots. It doesn't matter if I do garage 1 by garage 2 or 2 by 1. Either way would be okay. In fact, you can list them both on the same paired statement. So the two-sided test, we're seeing the same numbers. I just end up with the two-sided confidence interval. Sorry, I thought I got this one fixed. So this mark here is the absolute value bar that goes with t. Okay. And so here, this is our confidence interval. Notice there is no plus infinity or minus infinity for one of the endpoints. But all the information then, in terms of the summary information, this is going to match the first one because I did garage 1 minus garage 2. Before I talk about the plots, are there any questions then on the different approaches? So definitely if you're doing a two-sided test, then you're going to do sides equal 2. If you forget to specify, it's going to do two-sided. Okay? So the one-sided options are recent modifications to Proc t-test. So I'm glad they're there. All right, then now the plots. Okay, up here, Proc t-test, I didn't put any information about the plots, just at the very top of the program. I had the graphics turned on, and that's why it worked. These next images came on. Left. Okay, so these were a part of the right-sided test, and so I don't have page numbers on mine, all right? And we came to our conclusion, and here are some graphics that can illustrate your findings. We hadn't talked about this red line in terms of kernel, but do look at the blue line. It's for a normal distribution here, and that's where the difference is. If we had a normal distribution centered at D bar, what would it look like? And this is the normal distribution. We can see that might be under suspicion whether we had normally distributed data or not. Right? That histogram doesn't look very normal, does it? Okay. We also have a box plot down here of the differences, and then the shaded part, this corresponds to this lower value here. That corresponds to that confidence lower limit, that 0.4340. That's what's going on right here, the shaded area. So this is the confidence lower limit. Now, if you turn the plots on for a two-sided interval, this blue box is going to have a right side to it as well. Or if we had the plots on for the left side test, okay, everything here would be flipped to the other side of 0, and then this shaded blue area would be to the left. It would go negative infinity up to the confidence upper limit. Okay? So those are just a couple of things that we can look at that kind of graphically support or illustrate what we've done. Okay, this confidence lower limit is well above 0, our hypothesized value. If you have very many data points, this can get awfully congested. If you're doing this in black and white, it's harder to read. Okay, so if you print it in black and white, hopefully you got one bold line and the other's not so much. Okay, the red line is the mean here, so the garage 1 mean, and this is the garage 2 mean, and they're just connected up. And so each line represents a car that was evaluated at each of the garages. And so you notice there's a slightly negative slope on each one of these, meaning garage 2 is a little bit lower than garage 1 for all those. So this is just referred to as a profile. If you had a very large sample, such as our energy consumption with 60 families, this graph would get terribly congested. Okay, you'd be difficult to read. For small samples, it's not too bad. Okay. The agreement plot. Okay, first of all, there's a box around this, and that's really serving as a legend in there. That's not too crazy about that. It's trying to show you where the mean is. So if you come over here, garage 1's down here, garage 2 is over here. The garage 1 mean was 7.38, I think, and then the garage 2 mean this direction. So what were those values? Pardon me, I said 7. Garage 1 is 6.8, garage 2 is 6.23, and that's what this dark circle is centered at, is at the coordinates of those two means. A QQ plot, we had one of these off of Proc Univariate that looked, when we used a plots option, and it looked really ugly. Okay, this is what they're supposed to look like. All right, we have a reference line at this 45-degree angle. If our data are normally distributed, the data points will tend to lie close to this line. The more severe the departure from normality, then you'll see these data points deviate from this line a lot. So usually in the tails you'd see it, and so if you end up with several data points trailing off to one side and up here, or could be the reverse image of that, that's an indication of some departures from normality. Small data set here, it's not too bad. We can formally test it. But those are the plots that we get, and so I chose then on the next two t-test procedures to suppress the plots. All right, so this one there is no plots option here. Plots equal none, plots equals none is why I didn't get those 4 images 3 times. Okay, I turned them off down here. Each plot has a name, so if you're interested in one of them, There are some more programming things you can do where you can name exactly the single plot you want, but for right now, just getting started, they're either on or off.